Functioning of syntax and semantic analyzer. Suppose we have this grammar is equals to e plus t oblique t, t tends to t star f oblique f, and f tends to id oblique constant oblique constant. This grammar constructed by the parser, and what we have x is equals to y plus z to 60. This is given to us. So now I'm talking about the functioning of syntax analyzer. So what it will do, it will just create the tree, parse a tree. So how we are going to do this? Suppose we have s tends to id is equals to e. So we are going to write the grammar like this: s tends to id comma 1, as we have seen in the last lecture how we are going to how lexical analyzer is creating the tokens from this statement. So according to that, the syntax analyzer is working on it. Whatever the output of the lexical analyzer, that will be the input for the syntax analyzer. So id 1 is equals to e, and e plus t, and e tends to t. From this grammar, e tends to t, t tends to f, and f tends to id 2. Second identifier. This is the first identifier because x is equals to y plus z into 60. So we are taking starting symbol of the grammar, and this is the first identifier is equals to e. We are taking from this grammar. So now e plus t. So e tends to t, t tends to f, and f tends to identifier. Second identifier. This is a plus symbol. X is equals to y plus. Y is the second identifier. X is the first identifier. So x is equals to y plus. And because this is z into 60, so how we are going to break it? We are going to break it further, t into f from this grammar. So t to f, and f, it will be third identifier, and f, what is it? I dot constant, or we can say integer constant, because 60 is integer constant. So its value will be 60. So this will be the output of the syntax analyzer. From the grammar and from the statement, it will just create the parse tree, and whatever the input of the lexical analyzer, it will be the output of the syntax analyzer. And now the working of semantic analyzer. What it will do, it will check what is the type of the grammar, and type is float or integer of the identifier from the symbol table. Semantic analyzer it do type checking, it do type checking. So from this grammar, what it will see, it will type what is the type of that identifier. That if from the symbol table, it knows that this is the float type. From the symbol table, it will get to know that this is the type of float. So if type is not defined in the table, then this is called undefined symbol. If it is not defined in symbol table, then this is not defined in symbol table, then this is called undefined symbol. and error occur. So the type of the identifier defined in the symbol table, and if it's not defined, then undefined symbol, or it is called the error. So this is the function of the semantic analyzer to check the type of the identifier. So this is also float, this is also float given in symbol table, and this is also, suppose we are supposing this is also given float in the symbol table, but here we can see clearly that this is type of integer. 60 is a type of integer type. So what happens, what happened, because operation happens between two, or we can say operations only happens when the identifier are of same type. So because this is integer, so it will do typecasting. Semantic analyzer, what it will do, typecasting. So what it will do, that means it will convert integer to float. What it will do, it will convert integer to float, because for the functioning identifier type casting should be same, so it automatically change this identifier into float. So here there is no error, because integer because float take more memory than integer, because because it is converting integer to float, and because float take more memory than integer, so there is no problem, and there is no error will not be occurred. But if reverse, but if reverse, suppose we are doing float to integer type, then error occur, because float is taking more memory than integer, so then error occur. So there are two type of typecasting, we can say implicit and explicit. Implicit, that's done by compiler, and explicit, that is solved by user. So here we can see clearly that this kind of integer to float, because this is integer and all our identifier are float, so we need to convert it into float, and this is done by the compiler. So this is called the implicit type of conversion. But if it is opposite, suppose we are converting float to integer, so this will give us error. So in this case, the user need to solve this problem, and the user need to convert into the whatever type we need. So this kind of change is called explicit, and whatever done by the compiler, this kind of change is called implicit. So in that way we can do the functioning, and we can this is the working of semantic analyzer, the type checking, whatever we are doing, all are of same type or not. So this is the functioning of semantic analyzer, and how to create a parse tree from the output which is given by the lexical analyzer. This is the functioning of the syntax analyzer, and the type checking, this is the functioning of the semantic analyzer.